Welcome to what will be pre-lecture 20. We're going to start talking about thermodynamics and thermochemistry. So, thus far in class, when we've talked about energy instead of matter, it's generally been in regards to the electromagnetic spectrum as the way we've thought about radiation or energy. We're now going to shift our thinking to movement and heat as forms of energy. And specifically, or more specifically, kinetic energy and potential energy. Okay, so kinetic energy is our energy of movement. Basically, anytime you see the word kinetic, that means we have something moving around. So think about speed. Translating is a fancy word for moving, or rotating is another form of kinetic energy. We also have potential energy. That is more energy based on position. And so this has to do with the location of particularly charged particles. So think about protons and electrons next to each other. It could be something like gravitational potential energy. The key is essentially determining the distance between our objects. Okay? And then what we often care about most is how energy transfers between objects. And in chemistry specifically, we're going to be talking more about the energy that is associated with the making and breaking of chemical bonds in a field that we typically call thermodynamics. Okay, so that's what we're going to be dealing with for the rest of this week and probably a little bit of next. So imagine that we have six carbons in the gas, or 2 carbons in the gas state, 6 hydrogens, and 1 oxygen. All of these are just gases, like we pulled them right off the periodic table. And if they came together and formed bonds to make this Lewis structure, to make a molecule called dimethyl ether, what would happen is they would release energy. They would release potential energy to the tune of 3,151 kilojoules, which is, of course, a lot of energy. Kilojoules, just as a reminder, joules are units of energy, kilo just means 1,000, right? So a question I have for you that we're going to start class with is, why does forming bonds release energy instead of requiring energy? So I want you to think about that. We're going to start class with that question. Another thing I want to talk about on the pre-lecture video is the difference between heat and temperature. And so typically when objects transfer kinetic or potential energy, we refer to that energy as heat. So it might be easiest to think of heat as energy that is in transit. It's going between 2 different things. Okay? That is opposed to temperature. So temperature is a measure of the average kinetic energy of a molecule. I like to think of temperature as, or a thermometer as a molecular speedometer. And again, the heat is just the transfer of that energy. So temperature is measuring average kinetic energy of different bodies, different types of things. Heat is the transfer of the energy between those. Okay. Next up, if we're transferring between 2 things, we need to define them in some way. And so in thermodynamics, that tends to be talking about one thing as our system and the other thing as our surroundings. Okay. And so the system is typically in chemistry going to be our chemical reaction. And then our surroundings are everything else. And they are often separated by some sort of boundary. So we have an example here. Say we have a chemical reaction going on in this solution. The boundary is our beaker, and the surroundings are just everything else. We could also have a piston, and maybe our reaction is going on in that piston. We have some sort of boundary, and the surroundings again. Okay? So a lot of vocab in this pre-lecture, but one more concept we're going to talk about here are the laws of thermodynamics. In particular, we're going to talk about the first law of thermodynamics, which is hopefully pretty simple and intuitive. And that could be that energy is neither created or destroyed. Put another way, anytime we have a loss of energy in our system, that energy must go somewhere, and we are going to say that that goes to our surroundings. Okay, and then of course the opposite can be true. If our system gains energy, that energy has to come from the surroundings. Okay, so that's it for today. I hope that was clear. If you do have any questions, please do let me know. Otherwise, I hope you have a great day.